There you go. Wordle. Wordle. No, there's a reason behind it. I saw the word and I went, that'd be funny if you put no there. And L. Did I put L? Yeah. Oh, you put an L in water. And then I thought, oh, that's kind of like squirrel. You know, because like squirrel is the water. Yeah. Like, you know, water.
Excuse me. Where do we leave off, guys? Do we leave off this one? This look familiar to you or no?
I don't know. This point because
Do you have 2 examples in your notes so far?
Yeah.
Okay, then we're ready for this one. Because I'm telling you the PowerPoint is an example too. Okay? So we're ready to go. This is in your notes, we're going to talk about it, okay? Well, let's talk about it here right now, okay? Because if you notice, something's different about this one, right? Okay? So what's different about this one? You notice something different right out of the gate. Okay, what did you notice? We don't have a variable by itself this time, do we? One of the equations is not solved for a variable. That made it real easy last time to get one of the values of the variables real quickly, correct? Okay. But is it possible that we can make that happen? Could we solve one of these equations for one of the variables? Okay. So in your groups, I want you guys to discuss real quickly what makes the most sense to do. Okay. Which equation should you use and what variable should you solve for? Okay. What makes the most sense to you as a group? And we'll discuss on the other side. Take about 30 seconds and have that conversation. Go.
No, I thought someone said
Oh, wait, about face here? I thought I heard something else happening here at the beginning. Okay. You guys all three talked about it over here in the red group?
Which one are we doing?
Which one do you want to do, Eliza? You guys all have an idea?
I think so.
Yeah.
Three group, you guys have an idea? Okay. All right, I got all these dice. Ready? You know how I love rolling these dice.
I wonder if it's gonna land back there.
It's gonna land on Reed's seat, but he's not here.
Yeah. Didn't you get to take class? No. It was alright.
Your number.
Oh, it's my number. He just follows you guys.
I know it does, kind of, doesn't it?
It's not kind of weirdly.
Okay. And what did you guys decide to do?
We solved equation number 1 for x.
So you decided to solve equation number 1 for x. Why did you decide to go that way over some other possibilities?
Because it has the least work required. All you're doing is adding 7y to each side and then you're done.
Okay.
You don't
All right.
have to divide or anything else.
Okay. What anybody see something different than that? All right. So everybody's in agreement that that might be the best way to go. All right. And I agree too. All right. So nice investigative work on that one, guys. Okay. When you use the substitution method and you don't have a variable already solved in one of the equations for an expression, the best thing to do is to pick the variable in either equation that has the smallest coefficient. Okay, you know what the coefficient is, right? Coefficient is the number before the variable. Okay? So if you look up here, x in equation 1 has a coefficient of 1. That's the smallest coefficient of all four. 1, -7, 6, and 4. The objective here is to try to avoid fractions if you can, right? And if you solve for one of the other variables in this case, you're going to have to encounter some fractions somewhere. All right? It's going to make your lives a little more difficult when you're trying to solve these on your own. Okay? So try to avoid fractions if you can, all right? What are you looking for? Smallest coefficient of one of the variables. All right. You guys did a really good job on that. Let's go ahead and get going on this and see how far we can get today, because you got to get your substitution practice done tomorrow and submit it for me, okay? All right, so you got to solve for x or y here. There we go. Well, internet has not been doing very good today, so hopefully this will keep up with me here. We'll see. Okay, so again, we're going to solve equation 1 for s because the coefficient is 1 on x, okay? So let's do that. We'll solve, we'll add some y to each side, right? Whoops, hold on. What do you get? X equals 7y plus 10. Look good? Okay. So then this is what your system's going to look like now, right? Now, there, that's better. All right. Which expression gets the box then? Remember on Tuesday we talked about boxing one expression somewhere? Okay. Caitlin, which expression gets the box? All those in favor, say aye. Aye, I agree. Okay. And what variable in equation 2 will get the arrow? Where's the arrow going to point to? Sadie?
6x.
Yep, it's going to point to the x in equation 2. Okay. So this gets the box, arrow goes there. Everybody okay with that? Okay. So then rewrite equation 2. Okay. Rewrite equation 2. And if you do it correctly, okay, you should get this expression down there at the bottom. Or equation, I should say. Excuse me. All right, you guys ready to go ahead and solve this one? Solve for y, and then we'll worry about plugging it in, okay? Everybody good so far? Raise your hand. What's y equal? Brandon?
-1.
I get -1 also. How about everybody else? Oh, sorry, Mason. I'll give you a chance to speak to catch up, okay? I hope you guys have noticed that this routine is the same, right? Every single time we do a new problem, we do the same steps in the same order. Okay, that's the whole point here, okay? We do the same thing in the same order, it's just different numbers we're working with, and maybe different setup once in a while. But once you get the initial setup taken care of, you're golden, okay? And these are the kind of hard, these kind of problems like this are the hardest kind that I can give you, all right? Or an equation that already solved for a variable. All right, ready to catch on? All right, so now you have to pick equation 1 or equation 2 to get the value of x. right? So I'm going to use equation 1, just for convenience here. Okay? Now, here's the thing with this. I want to make sure everybody here knows real quickly before we move on, okay? Since we rewrote equation 1, you can use either form, all right? You can use this form, which is the original form, and plug in -1 here if you want to. Or you can use your new rewritten form, this one right here, all right? Which might be a step easier. Do the same equation, you're going to get the same result, as long as you do the math right, all right? It's your choice. Or, if you don't like it, you guys love choices, right? If you don't like any of those two options, there's always equation number 2, all right? So just pick one and go with it, okay? Again, at this point, it's your choice. I'm going to use equation 1, okay? I get x. So what's x, everybody? Yep, very good. X is 3, y is -1. Are we okay with this? Excellent. Any questions for me? Any questions for me? Let me come through again. Good. All right. Well, you try one on your own. Okay? So you can do with it. I'll kind of eavesdrop. All right, try this one on your own. Nice work, everybody. Like what I'm saying. Good job. If you're not sure about an answer, you'll be a text that. Your answer's not going to be a text. The answers will be integer, so I'll give you that much of a clue. Okay? You get an answer that's not kind of result in an integer, you need to go back and make some changes somewhere. Okay? You're 5, yep. Yes. Everything. Everything's in the box goes in that parenthesis. What's up, Sadie? Well, you check that in a minute with your roommates, okay? That looks pretty good to me. Okay, I think we're almost ready to do a group chat. Remember, we're not going to see each other on Monday. That'll be typically your next in-person day, but that's Martin Luther King Day, so we're out. Okay, so I won't see you again until next Tuesday. Okay, that is an NWEA day. So you got kind of 4 days without being here in a row. So 2 or 3 days. All right, shall we do group mates, guys? I think I'm pretty much done.
I solved it all. 34 and 13 this month. Like I saw you had 34, and I was like, it's over a fraction. It's over
The last one.
the last one.
Okay, Mason, which variable did you solve for?
So I solved the first equation for y.
Okay, did anybody do something different than that? So I think you have 14 followers. Okay, which is a great thing. You guys found the easiest way to go about the problem. Perfect. Okay, so I believe you subtract 3x from each side, right? And you get y equals negative 3x plus 5. That sound good with everybody? We're going to box that. It's going to go in for y right there, correct? All right. Now, we write equation number 2 over here. So I have 2x minus 5 times negative 3x plus 5 equals 9, which will be your negative 5. So 2x plus 15x minus 25 equals 9. Sound good so far? Okay. When you like terms, 17x minus 25 equals 9. Add 25. What do you get for x? I would agree. Oh, I wrote over it. Sorry, guys. We'll pretend that's not there. We'll make our own blank. There, x equals 2. Okay? Now what? Okay? Now what? What do we do now? What? Okay, so you want to use equation 1 in the solved form?
Yes.
Okay, that's fine. We can do that. So 1, y equals negative 3x plus 5 plus, replace your 2 with 2. So press x with 2. Oh, no. This gets kind of crazy. Okay, so sometimes this doesn't work. Y equals negative 3 times 2. Yes. Okay. Yesterday was a fiasco. Y equals negative 6 plus 5. Y equals negative 1. So the order pair is 2, negative 1. X equals 2. Y equals negative 1. Are we okay with that? All right, I think I have one more here of these. I'll show you real fast. Okay. And then I have an example 4 to show you, and we're going to be done. Okay. So we're just going to get through these, knock them out. Try this one now. mistakes, guys. Just practice. Okay, just gotta practice, get better with these methods. That's all it is. Okay. Tuesday, I'm going to show you the final way to solve the system using algebra techniques right now. There's actually another way you'll learn in high school, but right now we're just concentrating on these three methods. I'm going to have a group checker for each group, okay? So when you have an answer you think is correct, raise your hand. If you're right, I'll check you. If you're correct, you check the group mates. And Liz going to check group the blue group if she has the correct answer. Okay? Caleb's going to check the green group. She has the correct answer. That's what we with her. Okay? Mary's going to check the yellow group. He has the correct answer. That's what you got here, Mary.
I know, we get everything one
Go back to see what the answer is. That should be a fraction. I think exercise. I think actually positive. See what you have.
new subject. But we also haven't gotten new subject.
You can't substitute that yet because you're not in solving questions for X. You're not solving questions for X first. Okay? The idea is that you substitute in an expression with one variable and not two. Okay? So that doesn't help you find the stuff.
Like, you didn't get an algebra 1. Here's a whole year review.
I can get the right answer, but I'm not fast.
Adding on to that.
I remember the last in sixth grade, our teacher did not teach us everyone always took the teacher test, but then when she taught us,
Okay, 7. Subtract 2. Yeah, that's it. So make those changes and I'll try and make them work out.
Remember how Dr. say big brain?
Okay, all right, everybody having fun yet?
Yeah.
Looks like it.
Yes.
I'm being sarcastic.
This is fun.
All right, so I'm not going to work this one out because I saw what everybody did and everybody's pretty much on the same page with this. Okay. If you need help with this still, let me know. You know you can try to reach me. Okay. Just remember, you have to make sure that you have the equation solved for a variable before you substitute. All right. And you substitute that expression that variable equals into the other equation. Okay. The other danger that I need to make sure you guys realize is that you have to use both of these as a set, both equations. So if you solve this one for x, which is what you probably should have done, if you solve equation 1 for x, okay, you had to put that expression in for x into equation 2. You can't put it back into equation 1. Does that make sense? If you put it back into equation 1, something weird's going to happen. All right? You got to use them together. Okay? You got to use both of them together as a team. All right? So whichever one you don't manipulate and draw the box around, okay, you have to use the other one to substitute in. Okay? Any questions for me? X is 1 and Y is 3. For the answer on this one? Yeah. Good. Any questions? We good? You got substitution down pretty good now? Seems like it seems maybe it seemed kind of difficult at first, but like a lot of things in here, we practice it some, it gets a little bit easier. Okay? So yeah, X is 1 and Y is 3. Okay? All right. I think we're going to try one more kind of problem now. Okay? This is the last case of problem type for substitution that I can give you. All right? So I want you to write it down, turn and talk to your neighbor, okay, your group, turn to your groups and talk, and figure out a strategy for solving this kind of system. Okay? What might you do to solve this system for X and Y? Okay? What?
I did one of these on the homework yesterday. You did like
yeah, I think the wires.
you just plug it in.
Yeah, you would make the wire. If you wanted to put a wire, so
Probably just do 3x and make x plus 4.
this.
Really subtract x. Probably
divide
3. Oh wait, make it 2x. There it is. Equals 4. X equals 2. Plug 2 back in. Y equals 6. 6 minus 2 plus 4 is 6. Ella. Oh. That's math. It's just you do it the same way. You just go down and intercept.
equations are simplified.
Oh, yeah, but you need it.
Yeah, if you wanna find x, then you divide 3 on the first one. You know, just kind of.
You don't even know if there's any X. You don't even know if Y there's an X. Just take the second equation for. So you just take 3x in the first equation and plug it into y in the second.
Yeah, just subtract the
Okay,
second one.
you just have 3x equals
Easiest.
x plus 4. And then subtract x equals the right to the y.
And then you have 4 equals 2.
Oh, Mason did. I thought I remember that.
So, is X 2?
I'm not gonna tell you just yet.
Way to get ahead, dude.
Oh, yeah.
That's hurt my feelings.
All right, 5, 4, 3, 2, 1, 0. I've heard several different things being thrown out for a strategy. Okay, anyone want to volunteer for what they think they should do to solve the system? Eliza, what did you do?
I mean, you can't plug in something for x or y on the first one because we don't know any of the variables yet, so I
Okay.
just plugged it into number 2 since it actually has a number.
Okay. All right. Anybody else want to volunteer what they did? Emily?
Alright, so if you take 3x in the first equation, which equals y, it's pretty much the same as just having a y intercept of 0.
Okay.
But you would just take the 3x and plug it in for y in the second equation, so you'd end up with like 3x equals x plus 4, which then you could just simplify it to x equaling 2, and then just plug it back into and just plug 2 for x in the first equation.
Okay. So here's a little property from geometry you're going to learn a lot more about next year, but it's going to help us in this light for this problem. Check this out. Y equals 3x, right? Y also equals x plus 4. Y equals two different things, both in terms of x, right? This is called the transitive property. Here's what this says. If y equals this, and y also equals this, then these two things have to be equal. Okay? Because they both equal y. Y can't be more than one value. All right? So because y can only be one value, then 3x has to also equal x plus 4. That's how you get this set up. So you take the expression for y on either equation, box it, replace it with y in the other equation. The way you slice it, you'll get a correct answer.
Hey, yo, I got it.
Okay? Good. All right? Yeah. So this looks a little intimidating at first because they're both solved for y. So like you did it this morning for fire up. Okay? Just take one of the equations, solve for y, box that expression for x, plug it in for y in the other equation, solve it. Okay? So it's just a special case. Both of them are already solved for a variable. Don't let that throw you off the game. Okay? It's really just a special case. That's all. You guys ready to go for it? Okay, so I'm going to skip through this here a little bit. We're going to box 3x. We're going to mark it to y there. Okay? Everybody go with that screen? Good. Okay, so we have 3x equals x plus 4. Excellent, excellent. All right, so now we're going to solve this one. How do I solve this equation for x? You can help me out. Tony, go for it for me, please. Very good. They get 2x equals 4, right? X equals what? X equals 2. Everybody okay with that? Take your value of 2, pick either equation. They're both the same level of difficulty this time because they're really simple equations. Okay? Pick 1 or 2, plug it in. Don't make it any more difficult. So we're going to use equation 2 this time. Okay, so I have 2 plus 4. That means y equals what, everybody? Y equals 6. That's how it works. Okay? That's substitution. You think you guys can handle that? Okay. And then I have one more practice problem for you, and then we might start the next topic just a little bit so we have a little bit of a head start on it. Because remember, Tuesday's going to be a shortened period. I want to make sure we get through everything. Okay? So go for it. Solve this one and see what you can do. Same thing works for x too, okay? Same idea, just this x equals both equations.
Did you have negative 2 minus 5?
Oh, they didn't work out that minute. I was in my head and I got stuck. I figured it out, but geez. All right. Turn and talk to your group mates. Make sure you guys are all on the same page. Emily, I swear, you're in a hot seat right now. These dice just rolled your number again. Okay, but I'm going to give you a break this time. What? You want to try this one, Mason? Okay. All right, Mason's going to volunteer. What expression did you box?
Right. So I boxed the second one.
Y minus 5?
Yeah.
Plug that in for x here. I got y minus 5 equals negative 2y plus 1. So what are you going to do now?
So I subtracted 1 from both sides.
Okay. Those cancel out. So I have y minus 6 equals negative 2y.
And I subtracted 1y from each side.
Okay. So then I get negative 6 equals negative 3y.
Wait.
Change your signs we have to, remember. Negative 2 plus negative 1.
I did it wrong.
That's okay. Fix it right now with me. You can do this.
And then you divide by negative 3.
Yes, you would. What do you get for y?
2.
Y equals 2. Okay, we're okay with that one? Good. I'm just going to use equation 2 real quick. We'll basically make some changes here. X equals 2 minus 5, so x equals negative 3, right? So the order pair would be negative 3, positive 2, or x equals negative 3, y equals 2. Everybody okay with that? Okay, good. Now, I hate to do this to you, but I want to get a little bit of a head start here. We're not going to get too much involved with this, but at least we can get a conversation starting, okay? So, we're going to switch gears. We're not doing substitution now, okay? And we're going to talk about the third method on how to solve a system. We're going to just hit upon it a little bit today. Give you just a little bit of a taste, okay? Enough to tease you so you want to come back on Tuesday and want to learn how to do the rest of this. That's the whole thing, okay? You have to come back in. All right. All right, so let's get this now on this slide, okay? Don't worry about what that says. All right, so a new system here, okay? For this, I want you to try to solve it using a method called elimination. Like I did substitution, I'm not going to tell you what elimination means yet, all right? I want you guys in your groups to figure out what you think that means. What does it mean to solve a system by elimination? And then try some things. You can get an answer for X and an answer for Y, okay? So I want to hear some good dialogue here for a couple of minutes. What? Okay. Can't use substitution in this method in your guessing check either. They're not allowed.
One thing I could think of would be like eliminate one of the variables. Yeah, but that doesn't mean equate, because that would just be partition.
Oh yeah, all I can think of was to eliminate.
Yeah, that one means like, notice how they're like set up almost exactly. And like both you can standardify each other. Or kind of.
Just combine everything. Yeah. So it'd be 0. Yeah. And then
is standard.
Yeah, 2 is standard form. It's like
Anybody
one
have
and
any ideas what elimination means?
I get it.
It means to solve by elimination?
Wait, we could.
Yeah, I would be like eliminate a variable, but that would just give you answers.
You think?
Well, if you like eliminate y, and you're just
No, maybe it depends on how you eliminate y. You just say, boom, I'm gonna get rid of y and that's it, done, I'm done with it? Is that all you can do?
That one sounds super easy.
No more why.
And
that's how it works.
That's how it works.
Like,
I say, I want
no
to-
more.
Wait, like, very
That's how
much.
it works. Gone.
The
Don't like you anymore.
whole problem.
Fraction just next Harry Potter right there.
Hashtag Y is over party.
Okay, thoughts from the group? Anybody want to share a strategy that they might have tried? Emily just said, I have to share this with her because I think this is really kind of, and I'm not saying that it's funny, it's just funny the way you said it. You felt like, why not? Why can't I just say, I want to eliminate y and be done with it? That's why I think it's so funny. Okay?
Emily's
So you
hilarious.
just decided to eliminate y and be done with it. Okay? So, when you eliminated y, what's that mean? What does that, how does that affect the rest of the system here?
Well, you have like negative 4x equals negative 12,
Okay?
which would just give you a y-intercept of 3.
Or an x value
Or
of 3?
X-intercept, yeah,
Okay. So then if you figured out the x was 3, then how could you figure out what y was? You could do the same thing you did before,
Oh, you could just plug it into 2, or kind of, right?
maybe? What I thought, okay? What I thought. Eliza?
You said you'd eliminate one. Well, I would go with x because they're the same value. And we, for the first equation, we could just times every value by a negative number, turn them into a positive, and then they'd be the exact same variable for both of the x's.
Okay. Okay. All right. Who do I go to back here? Okay. Toby?
Okay.
He pointed to you first.
So, I was thinking maybe that you could like combine both of the like equations. So then basically it'd just be one equation.
How would you combine them?
So negative 4x would go to 4x, negative 2y would go to 8y, and then negative 12 would go to 24. Negative 24.
So then how would you be resulted with one equation then?
It's 1
But
point
x would be
one.
0 then.
So you combine these together is what you're
Yeah.
telling me? So how would you combine, what operation would you use to combine them together? Like you're adding these to get 0 here, right?
Yeah.
Would you do the same thing across on the other two columns, on this right here too? Or how would you get rid of the y's then? Or how would you do the y's then? Okay, well, you know what? Would you like to know?
Yes.
No.
I'll let you know on Tuesday.
Oh,
That's not fair.
Yeah.
Seriously?
What I will leave you with is there is enough talk in this room at this point to tell you that you guys are on track.
I don't like that.
Very close, okay?
I don't remember this being my.
But I love cocaine, so I have to give you guys one.
There's just, I've already forgotten you.
Fine. Be disappointed when I tell you something different on Tuesday.
I've already forgotten you.